The training objective of the FHIM-MDHT model-driven healthcare tooling vision is to show how FHIM can be simply and intuitively used in the SIGG Standards Implementation Guide Generator process. Although tedious and error-prone, the SIGG process can be done manually, where SIGG starts with FHIM domain archetype patterns, which are constrained based on a use case into detailed clinical models. DCMs can be specified as FHIR structure definitions or specified in other domain-specific languages such as the CIMI ADL architecture description language. DCMs can have SOLOR SNOMED extension for LOINC and RxNorm value or code sets bound to them. And DCMs can be fully CIMI compliant by following CIMI principles, which require DCMs to be derived from the FHIM-CIMI Reference Model archetype patterns, being iso-semantic with a preferred post-coordinated form, and being represented in CIMI ADL. Model-driven health tool referred to MDHT using FHIM can automate SIGG. MDHT can infuse standards while generating logical models and implementation guide versions. Although MDHT is not limited to HL7 standards, current focus is on designing and implementing HL7 Fast Health Interoperability Resource, referred to as FHIR, and HL7 Consolidated Clinical Document Architecture, referred to as CCDA template, implementation guide profiles, and extensions. HL7 FHIR APIs are mandated by ONC and CMS Information Blocking Rule for 2020 under the 21st Century Cures Act. HL7 CCDA standard is an essential part of the 2016 CMS Meaningful Use certification requirements for electronic health record vendors. The U.S. Office of the National Coordinator for Health IT, known as ONC, and the National Institute for Standards and Technology, known as NIST, use MDHT-generated Java runtime libraries of CCDA standard UML models for certification testing and verification that CDA XML documents satisfy all requirements under the meaningful use. MDHT is a suite of tools that are used to support the design and implementation of healthcare standards. MDHT delivers an open-source, standard object-oriented alternative to proprietary development methodologies and tooling used to specify and implement most healthcare industry interoperability standards. MDHT is designed to be used by authors of healthcare industry interoperability standards, 2 certification or testing authorities, and 3 software developers that implement adapters and applications that produce and consume healthcare data. MDHT uses UML use cases as input to scope each transformation. MDHT has constraint-based editing tools, specialized editing tools using terminology systems, and transformations to runtime Java libraries that support application developers and constraint validation. MDHT users can focus on the clinical content and not be overwhelmed by modeling formalisms. MDHT defines healthcare-specific UML profiles to specify interoperability standards and delivers model editing tools that are optimized for clinical informatics users, including a customized interface for the UML profile extensions. MDHT also delivers UML publishing tools that are used to generate specification documents that are ready for submission to standards organizations. Finally, the FHIM-MDHT tooling environment includes model transformations that leverage Eclipse Modeling Framework, known as EMF, and Object Constraint Language, known as OCL, to generate Java code used by healthcare implementers, where the core EMF framework includes a meta model called eCore for describing models and runtime support, including change notification, persistence support with default XMI serialization, and an efficient reflective API for generally manipulating EMF objects. A logical model repository is used to manage healthcare FHIM domain archetype patterns, DCMs, FSDs, and IGs, where they can be peer-reviewed, maintained, and published for software component developers and system interface implementers to use. MDHT or HL7 FHIR tools can convert FSDs into FHIR, CDA, etc. implementation guides. The IGs can simply be used or balloted and standardized and curated at HL7 for future reuse by component developers and interface implementers. Model-Driven Message Interface (MDMI) tool can use the design time logical model repository to specify semantically correct transformations from one message serialization standard to another. MDMI supports a computable representation of the semantics within each standard to harmonize data sharing among heterogeneous systems, different standards and varying standards versions. MDMI is